Hello everyone, welcome back. So when we last spoke with the previous video in this chapter, we introduced this concept of where electrons are in an atom with this model called the Bohr model of the atom. And so this cartoon down here is illustrating the Bohr model of the atom. In the Bohr model of the atom, electrons travel around the nucleus of the atom in specific paths that are called orbits. And in this particular example, we're studying hydrogen. And so in a hydrogen atom just has one electron. In this cartoon for the Bohr atom for hydrogen, electrons can be promoted to higher energy orbits by absorbing energy. And then electrons can fall down to lower state orbits by releasing energy that's in the form of light. So these orbits have particular numbers associated with them, particular n numbers. They are quantized. That means they have specific energy associated with them. The further away you travel from the nucleus, the higher energy that orbit has. So that's what we use to explain where an electron is in an atom with regards to hydrogen. And this model, this Bohr model, works great for hydrogen or species that just have one electron, which is great for hydrogen. It's what, got this scientist the Nobel Prize in the early 20s. But there is a problem with this model, and it turns out that once you start adding additional electrons to your atom, which is essentially all the other elements in the periodic table, once you start adding additional electrons to your atom, this model falls apart, meaning it does not completely accurately identify where an electron is in an atom if you start adding other electrons. Okay? So this model is great for hydrogen, not so great for other atoms. So we need another model. So when talking about this second model, we need to kind of shift our focus as to how we think about where an electron is in an atom. In the previous Bohr model, we thought of where an electron is in terms of orbits. It's either on orbit 1 or on orbit 2. It's either on that path or not on that path. In this model, we need to think more in terms of likelihood or probabilities of where an electron is in an atom. So before we talk about an atom, let's talk about a fruit tree or a cherry tree. If I was to ask you let's call it an apple tree. If I was to ask you where an apple will fall in this apple tree, once it falls off the tree, there's going to be some guesswork involved. There's going to be some probability involved. You're going to need to know something about which apple am I talking about, how many apples are there, how far away from the trunk is the apple. But by looking at this tree, you could see that it's more likely that I am going to find an apple from that tree closer to the trunk than farther away from the trunk. As I get further away from the trunk, the likelihood or the probability of finding an apple is going to decrease. Okay? So there's another way to say that is that there is a distance from the trunk with a higher probability of finding an apple than not finding an apple. If I was to plot what I just said, you could see there's a particular probability or a particular distance where it's more likely you will find an apple. So this likelihood, this probability of finding an apple from the trunk think about now in terms of an atom and in terms of 3 dimensions. In the Bohr model of the atom, we said that electrons traveled in specific paths called orbits. The electron was either there or it wasn't there. Now we need to think, instead of these defined orbits, which was in the Bohr model, we now need to think of this new concept of probabilities of where an electron is. And so we need to move from this concept of orbits to this concept of orbitals. I know they sound similar, they sound the same, but they're a bit different. Orbitals are specific regions of space, or if you like math, you can think about them in terms of solutions or probability maps as to where an electron resides in an atom. Okay. So I'm no longer going to be thinking about an electron as traveling around the nucleus in a specific elliptical path. That would be the Bohr model. This new model, which is going to be called the quantum mechanical model, thinks about electrons not in orbits, but in regions of space called orbitals. So we have now moved from this Bohr model with the specific paths to this new model of orbitals, where we have regions of space, and these regions of space, are in 3 dimensions, a region of space where it is more likely to find an electron. These little dots kind of show the probability, at least in this orbital, where it's more likely to find an electron. So this quantum mechanical or electron cloud model was derived by a very famous scientist called Schrödinger. So this is the model that scientists use to explain where an electron is in an atom for atoms that have more than 1 electron. Not in terms of the Bohr model with specific paths that the electrons have, but in terms of probabilities, regions of space where it is more likely to find an electron. So we're not going to do the Bohr model for atoms with more than 1 electron. We're going to do something that's called the quantum mechanical model. So you can see that these specific paths, these specific areas that the electrons travel in, has now been replaced by regions of space that have certain shapes to them that are called orbitals. So orbitals have shapes and energy associated with them, and we're going to talk about how you can designate those shapes and energies in the next video.